I'm Jeff Williams. I'm the CEO and co-founder of Exum Instruments, and we analyze stuff. That's it. That's the whole pitch. No, so
Yes. Yeah.
we are an analytical instrumentation company, and our focus is on analyzing solid materials. So, for the context of this presentation, I want you to think about aerospace metals. This could be nuclear fuels, biological materials, or even soils in remediation sites. And we want to revolutionize not only the technology, not only with technology that we've created, but the full experience of what it means to use an analytical instruments. For some context here, the picture on the left is the state of the art when it comes to analyzing solid materials. So think we take a piece of an aircraft wing, this could have been from the SR-71, that we really needed to have a very tight control of the metal that was being used to make that plane. And to analyze it, we have to put it into 3 different machines here, as you can see, in a full lab with ventilation, noble gases, 3 separate computers with 3 separate software package. You can see there's different keyboards on the desk there, and you literally have to time them at the same time. And we wanted to completely change this, not only from the cost of just buying the instrument, the cost of building a lab, and the cost of consumables are very high. And for most of the people that we talk to, that overhead has always been too much for them to say, mass spectrometry, no way, we'd rather just send this out. By contrast, the solution that we're providing, we call it the Mass Box. It fits on this desk. This is actually an image of me at the PitCon conference where we debuted this product. It has 1 power cord out the back, a touchscreen interface, and in 30 minutes, I could get everybody on this call ready to analyze any solid they want to know what it's made of. And maybe to give you a little bit of idea of who utilizes this. So one of our customers is Elementum 3D, and they service all areas of the Department of Defense. So whether they're providing powders for the additive manufacturing market for metals that are going into boats for the Navy or aircraft for the Air Force, or even other government contractors like Lockheed Martin or NASA as well. They service all of these companies. And every time they needed to ship powder, they needed to get QA/QC done on the chemistry. How much iron is in there? How much nickel is in there? Down to very low levels. They were spending thousands of dollars per sample, waiting for 4 to 6 week turnaround times. And on top of that, they needed to have a high-paced R&D environment. They weren't able to accomplish this by using external labs. We provided them a solution that took 4 to 6 weeks to 4 to 6 minutes and saved them hundreds of thousands of dollars per year and increased all of their cycles, whether that's the sales cycles from QA/QC before they can ship product, or R&D to offer the DoD more materials to print with to create better aircraft, better boats, and everything. Now, I know a lot of you haven't seen a periodic table since high school chemistry. That's okay. It doesn't matter. The only thing that's important here is this periodic table shows all the elements that we know of. And the ones that are colored are elements that we can analyze. And they're colored by limits of detection. You can think of this like the amount of cadmium in your food can't exceed 500 parts per billion. Well, we're able to analyze down to 100 parts per billion or less. So very, very low limits of detection for every laser shot that we do. And what I mean by laser shot is if you look at these 2 maps here on the right, every pixel that you see actually has the entire periodic table quantified. And we can move this sample in 3 dimensions. So you'll see we've created a chemical map on the first image, and then we've reanalyzed it on the second image. So we get depth information of the chemistry. So this could be a lithium battery, like what's shown here. It could be nuclear materials as well, analyzing the uranium isotope composition, thorium isotope composition, anything like that. Or it could be analyzing soils and remediation sites, wanting to understand how much arsenic is left there and maybe what mineral phase where the spatial information is important. So there's a lot of public sector applications for this instrument, and we're reducing that barrier of entry so you don't have to have a full lab, you don't have to have 3 PhD chemists and tens of thousands of dollars per month in consumables and operational costs. We want to make this easy, completely change the experience of analytical chemistry. With that, I'm going to leave it here, and our information is going to be in the chat as well as other locations as well. Please reach out if you have some applications idea. We're really, really excited to bring this out to you.